Good morning. This is Ms. Billerbeck, and we're going to talk about the first section in Math, Singapore Math 8, 1.1, and it's about positive exponents. So positive, of course, we know is 1, 2, 3, 4, 5, 6, and 0 is neither positive nor negative. So a to the n is the same thing as a times a times a times a times a n different times. Okay, so if we had n of the number of these a's multiplying with each other, that would be a to the n. So we have a to the m times a to the n would just be a to the m plus n. And a to the m divided by a to the n equals a to the m minus m. And then we have a to the m, and then the whole quantity to the n is a times m. So in each case, we have a different scenario. When we have a base with an exponent being multiplied, we add them. When we have a base with an exponent and we're dividing, we subtract. And when we have only one base with two exponents, we multiply. Well, that probably seems a little strange. So let's do some examples really quickly about what does this mean. You're probably confused. So let's take let's tidy it up. All right, so let's first talk about a to the m times a to the n. Okay, let's use some real numbers though. Okay, so let's use 5 to the third times 5 squared. Now we talked about, well, this means a to the m plus n. Okay, well, what does that mean? So if we expand 5 to the third out, that's 5 times 5 times 5. And this one's 5 squared. So we're talking about 5 times 5. Okay, so let's count how many 5s we have now. 1, 2, 3, 4, 5. There's 5 5s. Okay, so we just found out that this equals 5 to the 5. Well, wait a second. This says we could have just added the exponents. So let's try that. So if we added 3 plus 2 and remembered our base, since Miss Billerbeck did not, okay, we have to put our base here and then our exponents. 3 plus 2. Then 3 plus 2 we know is 5. Oh, look at that. We could have just done this and gotten to here versus expanding it out. So when it gets to be very large numbers, it's incredibly helpful to know this, don't you think? Yeah, because it'd be really hard to write like 20 of these, like 5 to the 20th times 5 to the 115. That would be horrible to have to write out all those and then add up how many 5s there were. So if we just add up these exponents, we save ourselves some time. All right, let's look at the next rule. So we have a to the m divided by a to the n. Whew. Well, they say that one is a to the m minus n. Okay. So let's try this out. Let's do 3 to the 4th divided by 3 squared. Okay, so that looks like this. So that's the same thing as 3 to the 4th over 3 squared, because that's all division sign is just that little fraction bar. Then let's expand it out. So we have 3 4s that are multiplying. And my little dot is a way of saying I'm multiplying. And then I have 3 on the bottom. Oh, look, we get to do a little canceling. So look, boom, because 3 over 3 equals, you got it, 1. There is 1 3 and 3. And look, we can cancel this one out. So then we end up, there's only 2 3's left after all that cancellation. So it's only 3 squared. Well, it's 3 squared over 1. But you guys know 3 squared over 1 is just 3 squared. Okay, so now let's take a look at the rule. Well, the rule says I could have just subtracted the exponents. Well, let's try that. 3 to the 4 minus 2. And we know 4 minus 2 is 2. Look at that. It's the same thing. So if these numbers are little, we can always expand it out. But if they're really huge numbers, we might want to know this rule. Okay. So now let's look at the very last one. So the very last one, we have a to the m, like that. And they're saying, well, that's just a to the mn, which means m times n. Okay, well, that really means a lot to you, I bet. So let's do 4 squared to the third. And let's take a look at that. So what that means is I've got 3 4 squareds. So I can write 4 squared times 4 squared times 4 squared. So I have 3 of them. I have 3 4 squareds. 1, 2, 3. Well, that also means 4 squared is 4 times 4. And then we have 4 times 4 and 4 times 4. So I have 3 4 squareds. So since it's just all these are multiplying now, I count how many I have. 1, 2, 3, 4, 5, 6. So this ends up 4 to the 6. Well, this rule says that I could have just multiplied those. So does that equal 4 times 2 times 3? 4 to the 2 times 3. Well, 2 times 3 is 4 to the 6. So it does. No more question mark there. So what we have is we have one base with 2 exponents. So that just means this chunk of term is being multiplied 3 times. Okay, so then we can expand what's in the parentheses if we want. If we can't remember the rule, we can always do that. But again, if these are really high exponents, this is a very nice little tool to remember, don't you think? All right, so these rules, though they look kind of weird, they save you a lot of time. All right, so now let's do an example. That's more in your book. So we have a to the 10 times a to the 8. Well, that means I'm just going to write a to the 10 plus 8, which is a to the 18. So if I use this rule, where I have a base with an exponent times a base with an exponent, then I just add the exponents. Okay, so that was easy. Now, ooh, look at this. That's not easy. Well, there's no exponents out here, so that's good. Well, what I would suggest is let's put the like things together. So we have 5 times 6. And once we've done that, let's just do a little mark like that so we know we did it. Times x to the third times x. Ooh, what exponent does this have when there isn't one written? I'm getting it from somebody. It's a 1. Okay, so then we have y to the 4th times y to the 7th. Okay, so now all we have to do is do this little part. Well, we know what 5 times 6 is. That's silly. And then this part, well, we add x to the 3 plus 1. And then this part, we're taking y to the 4 plus 7. So our final answer is going to be 30 to the x to the 4th and y to the 11th. And that's our final answer. All right, let's go to another example. Yikes, division. So if we remember our rule when we have division, here it is. Okay, so a to the m divided by a to the m, then it's a to the m minus n. All right, so we can rewrite this as q to the 17 over q to the 11th if we would like. So then we have q to the 17 minus 11. Okay, so our final answer, q to the 6, because 17 minus 11 is q to the 6. Yikes, look at this one. They're really raising the level of difficulty. Well, what I would suggest is putting one thing over the other, because that's what the division sign means. So let's do that. So we have r to the 9th, s to the 10th, over 6, and r to the 8th, over s to the 3rd. Now, if I'm not feeling super comfortable, I could just write 5 times 6, and then just start writing out these r's. So I have 9. 1, 2, 3, 4, whoops, 5, 6, 7, 8, 9. Oh my goodness, I'm not going to be able to do that. But you could expand it on the bottom, and then I'm going to just write s to the 10 because I don't have any room. But at least I can show you how to do it with the r's. Okay, so this is a case where it's good to know the rule. Okay, so we have 1, 2, 3, 4, 5, 6, 7, 8. And then we have s to the 3rd. Now we can see these r's just cancel away, and there's only one left. And we see the 6's cancel. So we have 5. Now if we had done the rule, we would have done r to the 9 minus 8 times s, and then the top exponent minus the bottom one equals 5 to the r, because remember when we did the little canceling war here, only one r survived. So we had s, and 10 minus 3 is 7. So that would be the answer for that one. Okay. I'd ask you if you had questions, and I knew you do, but we'll answer them in class. All right, let's look at example 3 now. I'll switch up my color here. Let's go with pink. All right, so we have b to the 9th to the 5th. Ooh. Well, that means I have b to the 9th times 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 b to the 9th. So I have 1, 2, 3, 4, 5. 5 b to the 9th. Okay, so if I just add those up, and I kept adding, I could simply say, well, there's 5 9, so 5 times 9 is 45. Well, hey, the rule was if I have a to the m to the n, it's just m times n. So that's the rule. So it's 9 times 5. So then I have b to the 45. Let's try that with this. Well, first let's do each one of these terms before we deal with this division sign. Okay, so if we know that we're multiplying those, this becomes c to the 6 times 8 divided by c to the 3 times 10. So we have c to the 48 divided by c to the 30. Well, the rule for that is, well, that's just c to and the 40 minus 30, because remember we have c to the 48 over c to the 30 is the same thing as writing it with a division sign, but with a fraction sign. So if we just say it's just c to the 48 minus 30, because if we had written out 48 of those c's and 30 of those c's, we could have canceled 30 of those 48 c's. So our final answer then is c to the 18. So only 18 c's would have been left after all those cancellations. Okay. All right. Well, they certainly are upping the ante on these. Okay, so let's do some more examples. So, look at this. We have to really know our rules by now. So this means that I've got 4 PQs. Let me use a different color so you can really see what's going on. Okay, so if I expanded this, that means I'd have PQ, 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 PQ 4 times. And this Q to the 5th, Q to the 5th, Q to the 5th, and Q to the 5th 4 times. Okay, and then this one would be P to the 3rd, P to the 3rd, P to the 3rd, P to the 3rd, and P to the 3rd, and I still have one more P to the 3rd, and then I have to do the same thing with the Q's. And let's see if I can, oh good, there's no exponent. I can just do this. Hopefully I can fit them. Oh, we just did 6 Q's. Okay, so that's what this is, all expanded. Well, not completely expanded, because we could still do a lot more expansion here. Okay, so the easy thing to do is, well, if we add those up, it would be 4 times 2. So why don't we just do 4 times 2 here? So P to the 2 times 4, 4 times 2 and 2 times 4 are the same because the commutative property of multiplication. And then Q 5 times 4. And then that's going to multiply, this time it's by 6. So we have P to the 3 times 6 and Q to, it's just 1 times 6 because this one doesn't have an exponent, it's just 1. So when we do that, we have P to the 8th, Q to the 20th, p to the 18th and q to the 6th. Well, now we can start putting things together. So we have p to the 8th, p to the 18th, q to the 20, and q to the 6th. So we can start adding those now. So we have p to the 18th, 8 plus 18, and q to the 20 plus 6. So we have p, and that is 26, and q is 26. Oh, look at that. They both ended up the same. Okay, so when we get a really tough one like that, it's really hard to expand it out. So these rules are going to help us out knowing when to multiply when we have an exponent out here, and when to add when we have a base with an exponent and a base with an exponent. Meaning I have 8 p's here, I have 18 p's here, so I want to add them together to find that I have 26 p's. I have 20 q's here, 6 q's here, and so when I add them together, I get 26 q's. All right, so the last example, yes, there is a last example. It looks like some of my things got a little erased here. Let me fix this a little bit. Okay, so, well, look at this, the last and final difficulty level. So when you see something like this, I would suggest let's figure out what this term is and figure out what this term is before we even get started. So we're going to multiply everything by 4. Or not multiply, but we're going to give this exponent to each one of these. So we have 3 to the 4th and a to the 5th times 4 and b to the 3 times 4. Then we're going to divide that. Hey, we have a squared and there's a negative sign. What do we know about 2 negatives? What do they make? What do 2 negatives make when you multiply? Remember? 2 negatives. They blow up. They go away. So I have a negative times a negative becomes a positive. So I don't need to worry about that little negative sign because I have an even exponent here, which would cancel that out. So now I'm going to write 9 squared and a to the 3rd times 2 because I'm applying that exponent. And down here I have b to the 6th times 2 because I'm applying the exponent there. So now let's figure out what all these are. Hey, I have something to think about. Isn't 9 equal to 3 squared? Can we substitute 3 squared in there? Let's do that. So let me write this out. So we have 3 to the 4, a to the 20. Down here we have b to the 12 divided by, and let's make this 3 squared. So we know, so this is 9 squared. So if 9 squared would be 3 squared squared. So 9 squared is the same thing as 3 to the 2 times 2, which is 9 squared equals 3 to the 4th. So that's a good thing to know. So this is 3 to the 4th. Then we have a to the 6th over b to the 12th. Okay, so we are dividing. This is a not nice problem for you. I'm very sorry. So let's think about how we're going to do this division now. So if we remember, keep, change, flip. So let's do that. So we have 3 to the 4th, a to the 20th over b to the 12th. We change to multiplication. We flip this over. So we have b to the 12th, 3 to the 4th, a to the 6th. Okay, so we just flip that. So now when we multiply this out, we have 3 to the 4th, a to the 20th, b to the 12th, over 3 to the 4th, a to the 6th, and b to the 12th. Aha! This is a much easier problem now. Look at this. 3 to the 4th and 3 to the 4th go away. B to the 12th and b to the 12th go away, because 12 minus 12, if I had b to the 12 minus 12, that's b to the 0, which is 1. Okay, so the only thing I have to deal with is a to the 20 minus 6. So after all that, this is the answer. Can you believe that? 20 minus 6 is 14. That was a brutal problem. You might have to watch that again. All right, so that's it for section 1.1. Have a wonderful day.